Welcome to our journey into the world of fluid mechanics. In this video series, we'll delve into the captivating concepts of fluid flow and pressure, fundamental to both engineering and physics. So what exactly is fluid mechanics? It's the study of fluids, both liquids and gases, and the forces acting upon them. This field is crucial as it helps us understand a wide range of phenomena, from how blood circulates in our bodies to designing efficient piping systems and predicting weather patterns. Without fluid mechanics, many innovations in engineering and technology would remain impossible. Throughout this series, we'll break down these complex ideas into understandable segments, starting with the basics and gradually advancing to more intricate concepts. By the end, you will have a firm grasp of how fluid mechanics impacts our everyday lives and the world around us. Let's get started with our first topic, a closer look at the fundamental principles of fluid mechanics. You'll soon discover how these theories apply to real-world scenarios, revealing the unseen forces at play all around us. Welcome to the fascinating world of fluid mechanics. In this segment, we'll dive into the foundational concepts that define this essential field. Fluids are substances that can flow and take the shape of their container. They are all around us, existing as either liquids or gases, each with unique properties. Liquids, like water, have a definite volume but no fixed shape, while gases, like air, can expand to fill any container. Understanding these basic distinctions is crucial as we delve deeper into fluid dynamics. We also need to consider the properties of fluids, such as viscosity, which measures a fluid's resistance to flow, and density, which is the mass per unit volume. These properties influence how fluids behave under various conditions. By grasping these fundamental concepts, we lay the groundwork for understanding more complex topics in fluid mechanics. Let's continue our journey and explore the intriguing dynamics of fluid flow and pressure in greater detail. Fluid flow can be categorized into two primary types, laminar and turbulent. In laminar flow, fluid moves in smooth, parallel layers with minimal mixing between them, creating an orderly and predictable motion. Think of a calm river, where the water glides along in a straight path. In contrast, turbulent flow is characterized by chaotic changes in pressure and flow velocity. It's the erratic movement you might observe in rapids or the swirling patterns of smoke rising from a fire. These contrasting behaviors are fundamental in understanding fluid dynamics, impacting everything from engineering designs to natural systems. Laminar flow, smooth and controlled, is often desired in systems requiring precise fluid movement. On the other hand, turbulent flow, with its eddies and vortices, can enhance mixing and improve heat transfer, making it beneficial in various industrial applications. Recognizing these two types of flow and their unique characteristics, we can better design and optimize systems reliant on fluid movement. Stay tuned, as you'll see how these principles apply to real-world scenarios, deepening your understanding of fluid mechanics. Now let's delve into the concept of pressure in fluids. Pressure is defined as the force exerted by a fluid per unit area. Whether we're talking about liquids or gases, pressure fundamentally governs how fluids behave. Imagine the immense pressure at the depths of the ocean or the atmospheric pressure that surrounds us every day. This concept is not just theoretical, it's practical and paramount. In liquids, pressure increases with depth. This is why divers feel greater resistance the deeper they go underwater. In gases, such as the air we breathe, pressure is exerted by the collision of air molecules with surfaces. These principles find applications in diverse fields, from hydraulic brakes in vehicles to predicting weather patterns. Understanding pressure is essential for grasping fluid mechanics. For instance, hydraulic systems use fluid to transmit power, relying entirely on pressure differences. Weather forecasting models also depend on understanding atmospheric pressure variations. Stay tuned, because up next, we'll explore the wonders of Bernoulli's principle and its real-world applications. Now that we've grasped the basics of fluid flow and pressure, it's time to explore a key principle that revolutionizes our understanding of fluid dynamics, Bernoulli's principle. Bernoulli's principle states that as the speed of a fluid increases, its pressure decreases. This relationship is captured in Bernoulli's equation, which is fundamental to many applications in both engineering and nature. Imagine the wings of an airplane. The shape of the wings causes the air above to move faster than the air below, creating lower pressure above the wing and higher pressure below, resulting in lift. Another everyday example is the carburetor in an internal combustion engine where the fuel is mixed with air. Bernoulli's principle causes a drop in pressure, drawing fuel into the airflow, enabling efficient combustion. Understanding Bernoulli's principle helps in designing cutting-edge technology and demystifies the workings of natural phenomena. Stay with us as we debunk common misconceptions about fluid mechanics to deepen our comprehension even further. In the realm of fluid mechanics, misconceptions abound. Many believe that fluid particles always travel in straight lines or that they flow exclusively from high to low pressure. However, these are not always true. Fluid flow can be highly complex, influenced by factors like viscosity and temperature. Some assume that faster fluid flow always means lower pressure due to Bernoulli's equation, but this applies specifically to streamlined flow and ignores factors like turbulence. Let's dissect these misconceptions and shed light on the accurate principles governing fluid dynamics. Understanding these truths is vital for mastering fluid mechanics. As we move forward, you'll see how these clarified concepts apply to real-world scenarios, enhancing your grasp of fluid flow and pressure. Fluid mechanics is a part of our everyday lives, woven into the fabric of nature and engineering alike. Imagine the flow of blood in our veins. It's a perfect example of fluid mechanics in nature, where the principles of fluid flow and pressure ensure our survival. Now, think about the majestic flow of rivers and the swirling patterns in hurricanes. These natural phenomena are governed by the same principles. In engineering, fluid mechanics is indispensable. Whether it's designing pipelines that transport oil across continents or developing efficient cooling systems for electronics, the applications are vast. Engineers harness fluid mechanics to optimize processes, improve safety, and innovate new technologies. Consider the intricate network of water supply systems in our cities, ensuring we have access to clean water, or in the aerospace industry, where fluid flow is critical for aircraft design. Stay tuned to explore more examples illustrating how these principles are applied and how problem-solving in fluid mechanics can lead to groundbreaking solutions. Let's solve some example problems to see how the principles of fluid mechanics are applied in practice. In this segment, we'll dive into specific scenarios and walk through step-by-step solutions to uncover the mechanics behind fluid flow and pressure. Understanding these real-world applications helps to cement the concepts we've discussed so far. First, we'll tackle a problem involving the flow rate in a pipe. By applying our knowledge of fluid dynamics, we'll calculate the velocity and compare laminar versus turbulent conditions. Next, we move on to a challenge involving pressure differentials in a hydraulic system. Here, we'll use Bernoulli's principle to determine how changes in velocity affect pressure and force. These exercises will not only test your understanding, but also highlight how fluid mechanics is essential in both natural phenomena and engineering marvels. Remember, each solved problem builds a stronger foundation for mastering these critical principles. Stay with us as we delve deeper into the challenges of fluid mechanics. As we reach the end, let's take a moment to summarize the key concepts we've covered in this video on fluid mechanics. We've delved into the fundamentals, including the nature of fluid flow and its two types, laminar and turbulent. We examined the concept of pressure, understanding how it applies differently in liquids and gases, and its myriad of applications in the real world. Central to our discussion was Bernoulli's principle, an essential idea that connects fluid speed to pressure changes, explaining phenomena ranging from the lift on an airplane wing to the functionality of a carburetor. We also tackled common misconceptions, ensuring a clear and accurate understanding of these principles. Lastly, through practical examples and problem solving, we saw how these theories come to life in both nature and engineering. By now, you should have a solid grasp on the essential principles of fluid mechanics and how they apply in various contexts. Stay tuned for our upcoming videos where we continue to explore the wonders of science. Don't forget to subscribe and follow our channel for more enlightening educational content. Thank you for joining us on this fascinating journey through fluid mechanics. We hope you've gained a deeper understanding of how fluids flow and the critical role pressure plays in our everyday world. If you found this video helpful and want to dive deeper into the wonders of physics and engineering, make sure to subscribe to our channel. By subscribing, you'll never miss out on our latest educational content. Also, follow us on all our social media platforms for regular updates and engaging discussions. Your continued learning and engagement mean the world to us, and together we can explore the intricacies of science. Stay curious, keep learning, and we'll see you in the next video. As we move forward, you'll see how fluid mechanics intertwine with other fascinating fields, bringing you closer to solving real-world problems. Thank you for watching and supporting our educational mission.